Welcome to the lecture series of Numerical Methods. Today we are going to discuss about Modified Euler's method. So how to do problem under Modified Euler's method? What is the difference between Euler's method and Modified Euler's method? Because our previous lecture video we have discussed about Euler's method, and today we are going to discuss about Modified Euler's method. Instead of approximating f of x comma y by f of x naught y naught in Euler's method, we approximate it by 1 by 2 f of x naught y naught plus f of x1 y1. First, by Euler's method, y1 equal to y naught plus h into f of x naught y naught. Then y1 of 1. First iteration is given by y1 of 1 equal to y naught plus h by 2 f of x naught y naught plus f of x1 y1. Here y1 of 1 is the first modified value of y1. We repeat this process. Let y1 of 2, that is second iteration, equal to y naught plus h by 2 f of x naught y naught plus f of x1 y1 of 1. y1 of 2 is the second modified value of y1. We repeat this process till the two consecutive values of y is same. Let y1 be the final value obtained to desired accuracy. Using the value of y1, we can compute y2. y2 equal to y1 plus h into f of x1 y1 by Euler's method. Now y2 of 1. y2 of 1 equal to y1 plus h by 2 f of x1 y1 plus f of x2 y2, and y2 of 2 equal to y1 plus h by 2 f of x1 y1 plus f of x2 y2 of 1. We repeat this process to calculate accurate y2. As the above, continue the process till we calculate yn. So this is the way we have to do problem under Modified Euler's method. So what is the procedure says? The procedure says that first we are going to approximate the value of given differential equation by using the equation half f of x naught y naught plus f of x1 y1. In the Modified Euler's method, before going for Modified Euler's, first we have to apply Euler's method. We know the result for Euler's method, yn plus 1 equal to yn plus h into f of x and yn. The base manner, that is the basic formula, is Euler's method formula. Using that we can calculate the first value of y, that is y1. Then we are going to get more accuracy value for this y1. To find out more accuracy only, we are using Modified Euler's method. So when you are doing a problem under Euler's method, we can get a solution for the given differential equation. When you are using the Modified Euler's method, we can get more accurate value for the given differential equation. That is the difference between Euler's method and Modified Euler's method. So when you are finding the more accurate value, for that only we are using Modified Euler's. So how to do problem under Modified Euler's? First you can use the Euler's result to find the first value of y1. Then we are going to get more accuracy. For that what we are doing? We are getting the iteration method. That is, the first iteration is denoted by y1 of 1. That is the first iteration of y1. Using the formula y0 plus h by 2 f of x naught plus f of x1 y1. This y1 is nothing but the value which you got by Euler's method. That value here we have to apply. So this is the first iteration value of y1. So the next iteration, that is, we are repeating the process to get the more accurate value. How we can stop the iteration? Until we get the two consecutive values are same, we can stop the iteration. That is the iteration process. So the second iteration y1 of 2 is nothing but y0 plus h by 2 f of x naught y naught plus f of x1 y1 of 1. Here y1 of 1 is nothing but the first iteration value of y1. This value here we have to apply to get the second iteration value. So you can do the process until we get the same value. Okay, so if you are getting, suppose in these two iterations the values are equal, we can stop up to this. That is our final y1. Okay, let y1 be the final value. Okay, so this is the more accuracy value of y1. Then we are going to find the value of y2. So how we are doing the process for y2? First by Euler's method, that is the Euler's method. y2 equal to y1 plus h into f of x1. So by using Euler's method, first we have to calculate the y2 value. Then for the modified value of y2, we have to use the modified Euler's result, that is y2 of 1 equal to y1 plus h by 2 f of x1 y1 plus f of x2 y2. This y2 value is nothing but the value just now we got by Euler's method. That value we have to substitute. Here y1 is the more accuracy value of y1. That value here we have to substitute. And then the second iteration of y2 of 2 equal to y1 plus h by 2 f of x1 y1 plus f of x2 y2 of 1. That is the first iteration value. So if suppose the values are not equal, you can go for the next iteration. How we can write the next iteration? y2 of 3, that is the third iteration, equal to y1 plus h by 2 f of x1 y1 plus f of x2 y2 of 2. This value we have to apply. Likewise, we can repeat the process until we get the consecutive values are equal. So finally we got the more accurate value of y2. Likewise, we can continue the process until we get yn. So after y2 you can repeat the process for y3, y4 etc. and then yn. So we have to do the problem according to the question only. So this is the general one, that is why we have used up to calculating yn. Okay. So look at the question and then we can apply the process of modified Euler's method. So now we will do the problem based on modified Euler's method. Look at the question. Use Euler's modified method to find the value of y for x equal to 0.2 when y dash equal to log of x plus y with y of 0 equal to 1 and h is equal to 0.1. So look at this question. In the question itself it's mentioned that use Euler's modified method. Okay. So here the differential equation y dash is nothing but dy by dx, which is equal to log of x plus y. This is our f of xy. The initial condition is given y of 0 equal to 1. That means x naught is 0, y naught is 1 and the h value is given, h is equal to 0.1. But the question is find the value of y for x equal to 0.2. Okay. So here h is equal to 0.1 means there is the first value x naught is 0, then the next value of x is x1. x1 is nothing but 0.1 and this is x2. Is it clear? So directly we can't find the x2. Before finding the x2, we are supposed to find the value of x1, then only we can go for the x2. So in this question, indirectly it's given that you are going to find the value of y1. We have to find the value of y1, then only we can go for y2. So try to understand the question clearly first. So use Euler's modified method to find the value of y for x equal to 0.2. That means we are supposed to find y2 when y dash equal to log of x plus y with y of 0 equal to 1 and h is equal to 0.1. If suppose this h value is not given, then you can take it as what? x1, the h value is 0.2 if it is not given. So look at the question, try to understand the question clearly, then you can proceed the problem. Okay. So now look at the solution. First we have to take the initial condition. What is given? The given condition is y of 0 equal to 1. We know that y of x naught equal to y naught. So what is our x naught? X naught is 0, y naught is 1. So which implies x naught equal to 0 and y naught equal to 1. The given differential equation. What is the given differential equation? Y dash. Y dash is nothing but dy by dx, which is our f of x comma y equal to dy by dx, which is equal to y dash. It's given that log of x plus y. Okay. So under the modified method, first we have to apply the Euler's method. That is what the procedure just now we have discussed. So by Euler's method, first we are going to find the value of y1. Okay. y1 equal to y naught plus h into f of x naught y naught. Okay. In this one, y naught value is given 1, h value is also given 0.1, h is equal to 0.1 and f of x naught y naught. Here f of x comma y is log of x plus y. So f of x naught y naught. What is our f of x naught y naught? Wherever x is there we have to make it as x naught and y is there we have to put y naught. So log of x naught value is 0 and y naught value is 1. Obviously this value is what? It is equal to 0. So now we have all the values y naught, h, f of x naught, y naught. Substituting all this we can get the y1 value. Therefore y1 equal to y naught 1 plus h is 0.1, f of x naught y naught is 0. So obviously our y1 equal to 1. This is by Euler's method we got. So what is the procedure says? The procedure says after find out the Euler's method we are going to modify this value, that is more accurate value of y1 we are going to find. So by using modified result only we can get more accurate value of y1. Okay. So my modified method, so by modified Euler's method, what is the formula for y1? That is y1 of 1. Why we are mentioning this? Because of the iteration. First iteration, formula is y naught plus h by 2 f of x naught y naught plus f of x1 y1. Here this y1 is nothing but the value just now we arrived by Euler's method. That value only we are going to substitute here. Okay, so before that f of x naught y naught value already we got it, and f of x1 y1 we have to find here. So f of x1 y1, what is that? F of x1 y1 equal to log of x1 plus y1. Okay, which is equal to log of, where it is x1 value is in the question. Here x1 value is not given directly. Instead of that it's given that h is equal to 0.1, x naught is 0. Okay, so if you want we can write it here. H is equal to 0.1, h is 0.1, x naught is 0. So obviously what is our x1? x1 is 0.1 because it's given in the question x2, right? x2 is 0.2. So this is the reason why we are taking x1 as 0.1. Is it clear how we are taking the x1? And plus y1. y1 is nothing but the value, here we got it. So 1 plus. So using calculator you can get the value of f of x1 y1 is 0.04139. Okay, so substituting all the values here we can get the first iteration value of y1. So y naught is 1 plus h is 0.1 by 2 into f of x naught y naught. F of x naught y naught is 0 plus f of x1 y1, that is the value of f of x1 y1, 0.04139. Okay. So using calculator you can get the accuracy value of y1 is 1.002. This is the first iteration value of y1. Likewise we have to go for y1 of 2, that is the second iteration. Okay, so similarly y1 of 2. y1 of 2 equal to y naught plus h by 2 f of x naught y naught plus f of x1 y1 of 1. Okay, so y1 of 1 is nothing but this value we have to apply here. Okay, so here also y naught value well known and h is known, f of x naught y naught, this value only we are supposed to find. What is that? F of x1 y1 of 1, that is equal to log of x1 is 0.1 plus y1 of 1.002. Okay, so using calculator you can get the answer as 0.04218. Okay, so this is our f of x1 y1. So substituting all the values here, y naught value is 1 and h value is 0.1 by 2 and f of x naught y naught is 0 and f of x1 y1 of 1 is 0.04218. And using calculator we can get the second iteration value of y1 is 1.002. Now look at this value, that is the first iteration value of y1 and the second iteration value of y1, both the values are equal, so we can stop the iteration. So what is our final value of y1? That is the more accuracy value of y1. Therefore our y1 equal to 1.002. Is it clear? First we got by Euler's method the y1 value is 1. After applying the modified Euler's method, we have arrived the result of y1 is 1.002. This is the more accurate value of y1. So the question is not finding y1, the question is finding the value of y2. Okay. So likewise, how we have proceed? By Euler's and modified Euler's and the iteration, we got the y1. By the same manner, we have to repeat the process for y2, because the question is find y for x equal to 0.2. The h value is 0.1. That is the reason why here we got y1. After completing the y1 only, we can go for y2. So how we have to do the y2? First by Euler's method. Okay, by Euler's method, y2 equal to y1 plus h into f of x1 y1. So y1 value is 1.002. This is the final answer of y1. That value only here we have to apply, not to first, that is the Euler's value 1 is there, no, you should not apply the value of 1. Final answer, that is just now we have got no y1 equal to the more accurate value, this value only. Hereafter wherever y1 comes, you have to apply this value only, not this one. Okay, so don't confuse all these things. Okay, y1 equal to 1.002 plus h value is 0.1 into f of x1 y1. F of x1 y1 equal to log of x1 is 0.1 plus y1 is 1.002. So using calculator you can get the value as 0.04218. Okay, so applying this here 0.04218, we can get the y2 equal to 1.0062. This is by Euler's method. So what is the next step? Next step we have to apply modified Euler's. Okay, by modified Euler's method, by modified Euler's, y2 result is y2. Okay, that is the first iteration value of y2. y2 of first iteration, y2 of 1 equal to y1 plus h by 2 f of x1 y1 plus f of x2 y2. Here the y2 value is this one, okay, which is equal to, okay, here y1 value is 1.002 and f of x1 y1 0.04218, f of x2 y2, this value only we are supposed to find. So f of x2 y2, okay, so f of x2 y2 equal to log x2 is 0.2 plus y2 value is this one, okay, 1.0062. So applying this we can get the f of x2 y2 answer is 0.0814. So now we got all the values. Substituting here, y1 value is 1.002 plus h is 0.1 by 2 plus f of x1 y1 0.04218 plus f of x2 y2 0.0814. Okay, so using calculator you can get the first iteration value of y2 is 1.0082. This is your first iteration value of y2. Okay, now we are going to find the next iteration value of y2. Okay, so y2 of 2 by modified Euler's method, y2 of 2 equal to y1 plus h by 2 f of x1 y1 plus f of x2 y2 of 1. y2 of 1 is nothing but first iteration value of y2, that value here we have to substitute. Here y1, h, f of x1, y1, all the values are known, only supposed to find f of x2, y2 of 1. So f of x2, y2 of 1 equal to log of x2 is 0.2 plus y2 of 1, that is 1.0082. which is equal to 0.08210. Okay, 0.08210. So now substitute all the values here. y2 of 2, okay, y2 of 2 equal to y1 is 1.002, h is 0.1 by 2, and then f of x1 y1 is 0.04218 plus f of x2 y2 of 1, this one 0.08210. This one is 0.04218. Is it clear? Okay. So using calculator, the y2 of 2, that is the second iteration value of y2 is 1.0082. Okay. So this is your second iteration value of y2. Now look at your first iteration value of y2. y2 of first iteration is 1.0082 and the second iteration is also same value. So we can stop the procedure. Hence our final answer of y2. This is our y2. More accuracy value of y2 is 1.0082. This is the accurate value of y2. First we got the value of y2 by Euler's method, and using modified Euler's method, the more accurate value of y2 is 1.0082. This is what given in the question. What is given in the question? Find the value of y for x equal to 0.2. So actually you can write like this, because we know that y of x2 equal to y2, isn't it? So based on this, the same result can be written as y of 0.2 equal to 1.0082. It's understood that y of x2, this is nothing but our x2 value. So this is the answer for the given question. Is it clear? So under the modified Euler's method, how to do the problem is, first we have to apply the Euler's method. Okay, Euler's method, applying that you can get the first value of y1, then applying the modified values we can get more accurate value for the differential equation. So that is the difference between Euler's and modified Euler's. Whenever you are using modified Euler's, first we have to apply Euler's method, then only we can go for the modified Euler's method. Okay, using this Euler's value only we are accurating the next values of y1 or y2. So this is the procedure under modified Euler's method. It's an important topic. Definite question will be comes under modified method. Okay, thank you for watching.